Hey guys, welcome to Biddy's Math Binder. Before we start, go ahead and take out pencil and paper so you can follow along with me. So we are doing transformations again today. However, we are going to look at reflections, the second type of transformation. We've already looked at translations, so now we move on to reflections. The definition of a reflection is a motion resulting in a mirror image. So basically just like a flip. So let's take a look at an example. I have ABC as my pre-image. I want to look at a reflection over the y-axis. So here is my reflection line on the y-axis. So I want to flip over that red line. Imagine if I physically took that coordinate plane and folded it over that line. It would appear to have flipped, created a mirror image of A prime, B prime, C prime. Now, under the reflection above, I want to change the following coordinates. So I'm going to reflect over the y-axis the point 1, 2. If you look, that becomes -1, 2 if I create that mirror image. Let's look at -3, -1. Again, I want to flip it over that y-axis. So if it's 3 to the left, I'm going to move 3 to the right to get 3, -1. -5, 5. Again, that's 5 to the left, so I'm going to move 5 to the right. So it's a perfect flip over that y-axis at the point 5, 5. Now if I look at 0, 4, that's on the y-axis. If I were to fold on that line, it would just land on itself. So I'm just at 0, 4. It didn't move to the left or to the right any, so it stays in the same place. Now that I've seen a few examples, I want to write an arrow rule to obtain the image of any point x, y under this reflection. So look at the table above and try to find a pattern. What I notice is that all the x coordinates change their sign. So 1 went to -1, -3 went to +3, -5 went to +5. Of course, 0 doesn't have any positives or negatives, so it just stayed the same. So my x changed signs, and my y's didn't change at all. So my rule is that x, y is going to change to -x, y. Let's look at another type of reflection. Again, I have my pre-image ABC, and now I want to look at a reflection over the x-axis. So let me draw my reflection line there. And again, it's going to flip right over that line. If I were to fold this graph right on that red line, they would match up. And I have A prime, B prime, C prime. Let's take a look at some other ordered pairs and see what they would become. So if I have 1, 2, that's 2 above the x-axis, so I want to go 2 below the x-axis to get 1, -2. If I have -4, -5, that's 5 below, so I want to go 5 above to get the point -4, 5. 5, 3 is 3 above, so I want to go 3 below to have a perfect mirror image at 5, -3. Then I have 0, 4, that's 4 above, so I need to go 4 below to create my reflection over the x-axis, which is 0, -4. Again, I want to come up with an arrow rule to obtain the image of any point x, y. Again, we're going to look at some patterns. This time, I notice that the x's are exactly the same. Nothing has changed about them. But the y's all changed signs. This is the rule for a reflection over the x-axis. Let's look at another example. Again, I have my pre-image ABC, and I want to look at a reflection over the line y = x. So we talked about a reflection over the y-axis and a reflection over the x-axis. Those were pretty simple. We should know where those lines are. But do we know where the reflection over the line y equals x is? Do we know where that line is located? Well, if you notice, that's in slope-intercept form. Y equals mx plus b, where m is your slope and b is your y-intercept. You should see here that there's just a slope of 1 and a y-intercept of 0. So I'm crossing the y-axis at 0 and going up 1 over 1 each time to have a slope of 1. That's the line y equals x. So we should feel comfortable with this from our previous math classes. Now I want to reflect over that line. If I fold over that line, I want it to match up exactly. Now I have my A prime, B prime, C prime, my image. Now let's do the same for the following coordinates. If I have the point 1, 2, I want it to go perfectly flipped over that red line, like so, to become 2, 1. Again, let's look at -4, -5. Perfectly flipped over that red line would be -5, -4. 3, 5, perfectly flipped over that red line would get me at 5, 3. And lastly, 0, -4. I want it to be perfectly flipped over that red line, and that would give me the point -4, 0. So look at the pattern, and let's see if we can come up with a rule for any point x, y. What I notice is each coordinate flips places. They switch. Instead of 1, 2, I have 2, 1. Instead of -4, -5, I have -5, -4, and so on and so forth. So my y actually comes to the front, and my x goes to the back. They switch places. That is the rule for a reflection over the line y equals x. One last new type of reflection. Let's take a look at our pre-image ABC. And I want to look at a reflection over the line y equals -x. This time the slope is -1, but the y-intercept is still 0. So I cross the y-axis at 0 with a slope of -1. Now I want to create a mirror image that perfectly flips over this red line. So now I have A prime, B prime, C prime, and if you'll notice, if I were to fold on that red line, they would match up exactly. Let's do the same with the points below. So if I plot the pre-image -4, 3, and I want it to flip over the red line exactly, that's going to give me an image at -3, 4. If I go to 5, 4, and I want it to perfectly create a mirror image, that's going to become -4, -5. To -5, I want to flip over that line y equals -x. That gives me the point 5, -2. And lastly, 0, -4, flipped over that red line to give me my mirror image is at 4, 0. So at this point, we should know the drill. We should look at the table above and figure out a pattern to come up with our rule to obtain any image from any point x, y. So when I take a look at my table, I see I'm going from -4, 3 to -3, 4. So I'm noticing the 4 and the 3 switch, but they're actually both opposite signs. Let me check the next one. 5, 4 to -4, -5. Again, they switch places, but the signs are different. Okay, to -5. I see that's 5, -2. Again, they're changing places, and the signs are both opposite of what they were. 0, -4 to 4, 0. Again, they switched places, and the signs are opposite. Okay, so what's happening is not only are they switching places, but they're changing signs. So y is coming to the front, but it's actually changing its sign. X is going to the back, and it's changing its sign. So for the reflection over the line y equals -x, our rule is xy changes to -y, -x. All right, now I want you guys to try on your own. take a look at the figure below, and I want you to state the transformation. Go ahead and pause this video and see what you can do. Then replay it to see what the answer is. So the way that I go about these is I pick a test point. So if I choose A, that's 0, 4. I actually cannot use that as a test point because it has a 0. Notice that when you have 0, you can't tell if 0 changes its sign or not, so that is not a good test point. Other test points that are not good are doubles. So for instance, 1, 1, 2, 2, 3, 3, because you can't tell if they swap places because they're the same number. So never pick a test point with a 0 and never pick a test point with double digits. Let's try B. Okay, B works. B goes from 2, 4 and then changes to 4, 2. Well, can't I figure out what the rule is here? What's that pattern? My X and Y are switching places. Isn't that a rule that we learned today? Doesn't that match with the reflection over the line Y equals X? If we look at it visually, we can see that if we were to fold over that line, the purple figure and the yellow figure would indeed land on top of each other perfectly. So the second question is write the rule. Well, if you figured out A the way I just showed you, you've already come up with the rule. XY change to YX. All right, guys, that's the lesson for today. Be sure and subscribe for more math videos. See you next time.